Okay, so this question is saying that we have two solutions and we are combining them together, and we need to find out what the concentration is of the different species of the glycine and NaCl inside our final solution. So let's draw this up. We start out with 50 mils. Okay, 50 mils of a 50 millimolar glycine solution. So in here there's 50 millimolar glycine. We have another solution over here, and this solution is 100 mils volume, and inside that volume there's 100 millimolar glycine, but there's also floating around 20 millimolar NaCl. Okay, so let's break this down. 50 millimolar is equal to 50 millimoles per liter, which is equal to 50 micromoles per milliliter. Okay, which means if we had 1 milliliter, we would have 50 micromoles. We don't have 1 milliliter, we have 50 milliliters. Okay, so over 50 milliliters, get from there to there, times by 50, get from there to there, times by 50, and this would give us 2,500 micromoles. And just to make this a bit nicer, let's convert it into a milli. So this would be 2.5 millimoles. All we've done is converted this micro to a milli. We haven't done any conversions over here, so let's keep that as 50 mils. Okay, so we can say in here, the amount of glycine floating around is 2.5 millimoles of glycine. The amount of sodium chloride floating around is nothing. Okay. Now let's do the same here. We have 100 millimolar of glycine, 100 millimolar glycine. This is equal to 100 millimoles per liter. And since we have 100 mils, which is equal to 0.1 liters, okay, this means that we have 10 millimoles of the glycine in this 0.1 liters. Okay, so in here, there's 10 millimoles of glycine, and for sodium chloride, 20 millimolar is equal to 20 millimoles per liter, which is equal to, in 1 liter there's 20, which means in 0.1 liters there are 2 millimoles. Okay, so there's 10 millimoles of glycine and 2 millimoles of sodium chloride. So when these two are combined together, okay, so this will be the final solution. The final volume will be 100 milliliters plus 50 milliliters. Okay, so this will have a final volume of 150 milliliters. Now in terms of the glycine, okay, there's 2.5 millimoles of glycine coming from this first solution, and there's 10 millimoles of glycine coming from the second solution. So the total amount, not concentration, the total number of millimoles of glycine is going to be 2.5 millimoles from the first solution plus 10 millimoles from the second. This equals 12.5 millimoles of glycine in total floating around in this 150 ml beaker, or 150 mils of solution inside this beaker. Okay, for sodium chloride, there were no millimoles coming from the first solution, and there were 2 millimoles coming from the second solution, which means the total amount, okay, not concentration, but amount, is 2 millimoles. So therefore we can say the final concentration of glycine is actually 12.5 millimoles, okay, 12.5 millimoles of glycine floating around in 150 mils. Okay, and the final concentration of NaCl is 2 millimoles floating around inside this 150 mils. Okay, now to express this in a nice way, what we can do is we can divide this side by 150, which means we divide this side by 150 as well. So let's get the calculator up. 12.5 divided by 150 50 is equal to 0.0833. Okay, 0.083 millimoles per mil. And this one will be 2 divided by 150 equals 2. Okay, so that one will be 0.0133 millimoles per milliliter. Okay, now that's a fairly ugly number, so what we can do instead is we can convert this over to a nicer number with a different prefix. Okay, so 0.083 millimoles is actually equal to 83 micromoles. Okay, and 0.0133 millimoles is actually equal to 13.3 micromoles. Okay, so we haven't converted the mils at all. We've just expressed 0.083 mmol as 83 umol. Okay, and we've expressed this side as micro as well. Okay, so the final concentration of glycine is 83 micromoles per milliliter. Okay, 83 micromoles per milliliter. But let's convert it back into a big M kind of format. Okay, and a big M format is moles per liter. Okay, so this side needs to be liters, and this side needs to be something moles. And so we've still got mils here. So this is saying that in 1 mil of this solution, there are 83 micromoles. This is the same as saying that in 1,000 mils of this solution, okay, there are 83,000 micromoles. 83,000 micromoles is the same as saying 83 millimoles, and 1,000 milliliters is the same as saying 1 liter. Okay, and so this is the equivalent to saying 83 millimolar. And so the final concentration of glycine is 83 millimolar, and the final concentration of NaCl will be about 13.3 millimolar as well.